Welcome to The Explainer. Today, we are taking on a genuinely mind-bending premise that's going to challenge a deeply held assumption. What if everything, and I mean everything, we believe about how our brains store memories is just a massive conceptual misunderstanding? Not a failure of the science itself, but a complete failure of how we interpret it. We're looking at a fascinating paper called The Turn by Ryan McLean, which literally reconstructs how we think about time, consciousness, and the human brain.
Okay, let's dive right into this. I want you to deeply consider a question for a second. When you remember your childhood bedroom or, just what you had for breakfast yesterday, does that memory actually live inside your head? We casually talk about our brains like they're computer hard drives, right? We encode files, we store them in our little neural folders, and we retrieve them when we need them. But is that actually what's happening physically? For decades, we've basically universally accepted what the source paper calls the container model, this pervasive myth that the brain physically holds memories inside itself like a locked storage vault. But the term proposes a radical alternative, which it calls the accessibility model. Instead of acting as a storage vault where your past is just locked away, what if your brain is actually more like an incredibly complex antenna? What if it's a receiver that simply enables you to tune into past relations, allowing them to resolve right now in your present consciousness? Now, what's really interesting about mapping this all out is that this entire paradigm shift isn't just some abstract philosophical thought experiment. The author completely dismantles the storage assumption and builds this new relational model by pulling directly from hard neuroscience, modern physics, and classical philosophy. It shows how changing that one core question changes absolutely everything. Your brain doesn't pull a memory out of a biological box. Rather, it enters a condition where an event from your whole history suddenly becomes accessible right now. To really understand how we got so intensely attached to the storage myth, we kind of have to look at the history of the science, which honestly is genuinely incredible. Ever since the 17th century, when Descartes first proposed mechanical physiology, scientists have been obsessed with tracing exactly how the body retains information. In 1904, Richard Semon coined the term engram to describe the physical trace of a memory. By 1949, Donald Hebb showed us how repeated neural activity strengthens brain connections. You've probably heard the phrase, neurons that fire together, wire together. And today, in the 2020s, the tech is absolutely wild. Neuroscientists can literally tag, silence, and stimulate specific neural ensembles, these engrams, to turn learned behaviors on and off in a lab. Now, hold on, let's be absolutely clear here. We are not dismissing these neuroscientific discoveries at all. The science is completely valid. Experience definitely changes the physical structure of your brain. The paper explicitly agrees that this physical neural modification changes your future capacity, and yes, your current neural state dictates how you respond to the world. But we need to look strictly at what those experiments actually prove and what they don't. They absolutely prove that the brain is historically modified. They do not automatically prove that a complete informational copy of your memory is just sitting inside that modified tissue. Think about it like this. The author calls this the strength error. Say you spend all summer doing push-ups. Your muscles physically change, right? Because of that history, you now have the capacity to lift heavier things tomorrow. But nobody in their right mind would ever say that your bicep literally stores a tiny, glowing jar of strength inside it. You didn't deposit an object, you just changed the system's capacity to act. The paper argues that persistent physical change in the brain proves a modified capacity to access a memory, not necessarily that the brain has trapped a stored object inside itself. And this brilliantly illustrates our next point, a second massive logical trap we constantly fall into, which the paper calls the light error, or the TV analogy. Imagine you're watching a movie on television, and you smack the TV with a pillow. The picture glitches out. You pull out a wire, and the sound completely stops. Well, you've definitively proven that the television is strictly necessary for the movie to play in your living room. The exact same thing happens in neuroscience. If you poke or lesion a specific part of the brain, a memory glitches or disappears. But here is the absolute crucial distinction for this whole explainer. Dependence does not equal containment. Just because a broken TV ruins the movie, that definitely doesn't mean the actors literally live inside the plastic box. The TV is just a receiver. Altering the receiver changes the output, absolutely. But it doesn't mean the receiver created the broadcast or that it contains the original source. When we study the brain, we continually prove that memory depends on the brain. We have not proven that the brain contains the memory. And, this actually isn't a new trap at all. Way back in 1898, the philosopher and psychologist William James noted, "The fatal conclusion of the physiologist flows from his assuming offhand another kind of functional dependence."
Science routinely confuses the local site where a function happens with the exhaustive origin of that function. We see the brain lighting up when a memory happens, so we just automatically assume the brain manufactured that memory out of nowhere.
Let's completely separate this idea of accessibility from storage with a practical and frankly delicious example from the paper, Angela's hidden cookie. Imagine you hide a cookie in the pantry and you completely forget where it is. You check everywhere. It's gone. Panic sets in. Then someone casually says, "Hey, didn't you hide it right after Dad walked in?" Boom. Instantly, the memory returns. Your failure to retrieve that memory a minute earlier didn't mean the memory was physically destroyed in your brain. It simply meant that your brain's present condition couldn't tune into it. Having access to something and the mechanism that makes that access possible are two totally different things.
Section 2, Physics and the Past, Elevating the Argument. Because think about it, if the memory isn't just a file stored inside your skull, where does the past actually go? To answer that, we have to look past biology entirely and apply modern physics.
Let's move to Minkowski spacetime and see how this builds our case. In Albert Einstein's special relativity and Hermann Minkowski's geometric model of it, we learn that space and time are unified into a four-dimensional structure. Why does this matter for memory? Well, because in physics, there is no universal now that acts like a giant cosmic eraser, just destroying the past the second you live through it. The past is not ontologically annihilated simply because you are no longer experiencing it. Therefore, there's absolutely no logical reason your brain needs to perfectly copy a vanished event, because physically, the event hasn't vanished from the space-time history at all.
Think of your life like an incredibly vast, open-world video game. The whole map of your life, your past, your present, your future trajectory, it all exists in the game's architecture. But your television is only rendering the single room you are standing in right now. The present is the only rendered coordinate. You don't have to simultaneously display the castle you visited 3 days ago for that castle to still exist on the map. It's a total light bulb moment when you realize your conscious experience is local, but your actual history is massive. So this brings us to the paper's alternative, what it calls the procedural rendering model. Rather than functioning as a storage unit, think of how all these elements work together dynamically. Your whole continuous history supplies the structural timeline. At the exact same time, your brain, the physical receiver, supplies the local configuration based on how it's been shaped by that history. Your current relations and cues then determine what becomes accessible to you right now, rendering your conscious experience right at your present coordinate. You aren't reaching into a filing cabinet. Your brain is acting as a local resolver, dynamically tuning into an intact relational history. The crucial takeaway here is that we literally have to rethink the brain's entire job description. As William James points out, we are not required to think of productive function only. We are entitled also to consider permissive or transmissive function. The brain doesn't have to literally produce your past out of thin air. Instead, it transmits and permits access to your own history. Let's just summarize this massive paradigm shift cleanly. In the old paradigm, we viewed the brain as a container, versus the new paradigm, where the brain is a resolver. We used to see memory as an isolated object, versus memory as an active relation. We thought the past was something entirely gone from existence, versus the reality that the past is simply a different coordinate on your continuous existing timeline. And honestly, this leads us to a place of just profound philosophical awe. The paper connects this to classical metaphysics, like Thomas Aquinas' concept of the first mover, this idea that the source of reality isn't just a physical push, but the ultimate source of relation and actuality. As William James so beautifully put it, consciousness in this process does not have to be generated de novo in a vast number of places. It exists already, behind the scenes, coeval with the world. Reality isn't just a series of isolated containers walking around, it is fundamentally, beautifully relational at its very core. We've covered a staggering amount of ground today, from the physical structure of synapses all the way to the four-dimensional geometry of space-time. But I want to leave you with a single, lingering thought that really flips everything upside down. If your brain doesn't actually contain your memories, if it is, in fact, just the receiver, what exactly is it tuning into right now? Keep asking questions, keep challenging your assumptions, and we will see you on the next explainer.